right, let's continue to work on changing a fraction into a decimal. I'm going to call this method 2. Method 2 is going to work for any number at all. Any number. Nice numbers, icky numbers, any numbers. This is kind of our go-to method. We're just going to use long division. That's all we're going to do. So here are kind of your steps if you are if you are a person that likes steps. Step number 1, we're going to write the fraction as a division problem if we need to. Make sure that we're writing it in the correct order. If you switch what you're multiplying, you will be solving a different problem. Step number 2, we're going to add zeros to the end of the dividend. That's the number that's underneath our division symbol. Some people call it the garage. We're just going to add zeros to the end of that because we can add as many zeros as we want. Number 3, we're going to divide until the decimal terminates. Terminates is just a fancy word for it ends. We have a remainder of 0. Or we find a pattern. We find some numbers that are going to start repeating. And then number 4, if the decimal has a pattern, if there's some numbers that repeats, we're going to draw a line over the part that repeats, and I'll show you what that looks like. Let's go ahead and start with some examples. Example 1, we're going to do 7/20ths, but we want to write it as a decimal. 7/20ths, well, I'm just going to rewrite it. There we go. And my number that I'm starting with goes, I'm going to call it under the garage. And the number I'm dividing by goes outside. So it looks like this. Make sure these are not flipped. Otherwise, you'll be doing a different problem. A lot of kids look at this and they get stumped because they're like, 7 doesn't go into 20, or 20 doesn't go into 7. You're correct. Not a whole number anyway. So that's why we're going to add a decimal to the end of our whole number and add zeros. I'm going to go ahead and just start with 3 zeros. I find that that's generally a good place to start. I might not use all my zeros, or I might have to add some more, but I'm going to start there. Step number 1, bring your decimal point straight up. We're going to divide like usual. 20 does not go into 7, so that's 0. 20, how many times does it go into 70? Well, it's 20, 40, 60. It goes in 3 times. 3 times 20 is 60. I'm going to subtract. Bring down my 0. How many times does 20 go into 100? Oh, it goes in 5 times. 3 groups of 20 is 100. And I have a remainder of 0. Stop dividing. You can stop right there. I didn't even need that extra 0. So in this case, our decimal terminates. This is called a terminating decimal because it ends. My answer is 0.35. 7 broken up into 20 parts. There is 35 hundredths in each part. Example 2, let's write 3/8 as a decimal. So step number 1, we'll write it like this. 3, our number that we start with, goes under the garage. The 8, the number we're dividing by, goes outside. And I'm saying, 8 does not go into 3, so I'm going to write my decimal. And I'm going to add 3 zeros. We'll see if that's enough later. Now I'm going to start dividing. Bring my decimal point straight up. How many times does 8 go into 3? None. How many times does 8 go into 30? Oh, let's see, 8 times 4 is 32. It's a little bit too high, so 3. 8 groups of 3 is 24. We'll subtract. Bring down the 0. How many times does 8 go into 60? Let's see, 7 times 8 is 56. 4. Bring down the 0. Oop, I see here. I'm going to be good. How many times does 8 go into 40? It goes in 5 times, straight up. And I get a remainder of 0. I am going to stop dividing. This terminates. So 3/8 is the same as 0.375. That is an example of a terminating decimal because it ends. Example 3, 11/3 as a decimal. Well, in this case, I know I'm going to get, this is more than 1, so I know I'm going to get an answer that's more than 1. I'm going to rewrite it. The 11 is going under the garage. The number I'm dividing by goes outside. Again, I see that this is not going to go on a whole number, so I'm going to add my decimal. And I'm going to add 3 zeros. And I'm going to bring my decimal point straight up and start dividing. How many times does 3 go into 11? See, it goes in 3 times. 3 groups is 9. Bring down the 0. 3 goes into 20, 8 times. Nope, not 8 times. 7, 6 times. Whew. 6 times 3 is 18. Get 2. I get another 20. Okay. Let's see. 3 goes into 26 times. 3 times 6 is 18. I get another 2. Bring down the... Wait a minute. I'm noticing a pattern. Do you see a pattern here? I got a 20 here. I got a 20 here. I got a 20 here. I notice that every time I'm going to be, 6 is going to go in there and I'm going to get a remainder of 2 and then add a 0 and then 6 will go in. I'll get a remainder of 2, add a 0. My pattern, this 6 is going to repeat over and over and over again. My answer is going to be 3.666666666. It's going to go on forever because I will continue adding zeros on and these 6s will keep happening. This is called a repeating decimal because my 6s repeat. So this is fine. This actually happens. Some fractions will be written as a repeating decimal, but my goodness, I mean, if I were to have to write out all these decimals, I would be writing them out forever, and I don't want to do that. So here's what we do. I'm going to write 3 point. My 6 is what's repeating, so I'm going to write my 6, and I'm going to put a little line or a bar over it. That bar right there tells me, hey, it's not 3.6, it's 3.666666666 repeating forever. So this is how I would write that decimal, 3.6 with a bar over it. All right, example 4. Just a hint, we are going to get a pattern with example 4, but it's going to be a little harder to find. You're going to need quite a bit of room here, so we're going to have to write a little bit smaller. See, we're going to rewrite this one. 55 goes under, 7 goes outside. Again, I know my pattern here, so I'm going to write my decimal, and I'm going to write 3 zeros, and let's see how this goes. Okay, bring up my decimal. Boink. 7 goes into 55. Let's see, 7 times. 7 times 7 is 49. And we get 6. Bring down the 0. How many times does 7 go into 60? Let's see, 8 times. 8 times 7 is 56. Get a remainder of 4. Bring down a 0. How many times does 7 go into 40? So 7, 6, 5 times. So 5. 5 times 7 is 35. I get 5 as a remainder. Bring down a 0. Okay, well, I ran out of zeros. It hasn't ended yet, and I'm not seeing a pattern. I'm taking a look at my pattern like I had a remainder of 6. I had a remainder of 4. I had a remainder of 5. I have no repeat remainders, so I'm just going to keep dividing, which means I'm going to add on some more zeros. I'll add on 3 more zeros. Just see what happens. All right, 7 into 50. Well, that's 7 times. So 7 goes up here. 7 times 7 is 49. Okay, get a remainder of 1. Still no repeats. Bring down another 0. How many times does 7 go into 10? 1 time. No patterns repeating yet. 1 group of 7 is 7. Get a remainder of 3. Let's see, 6, 4, 5, 1, 3. Nothing repeating. Bring down another 0. Woo! Am I going to run out of paper? We'll see. How many times does 7 go into 30? That's 4. 4 times. 4 times 7 is 28. Okay, remainder of 2. Let's see, I'm still looking. Let's see, 6, 4, 5, 1, 3, 2. Oh, no. Add another, okay. Keep bringing down that 0. How many times does 7 go into 20? What is that? Oh my goodness, brain fart. 7, 2 times. 7 times 2 is 14. I am totally running out of paper. Oh, but wait a minute. I see something. I have a remainder of 6. And right here, I also had a remainder of 6. That tells me when I add another 0 on here, add more zeros, when I add this remainder and bring down my 6, I'm going to start repeating at this point, because how many times does 7 go into 60? 7 goes into 60, let's see, 7, 8 times? 8 times, I'm going to get 56. Oh, 56. And that's going to give me a remainder of 4, and that's going to go in. So I'm going to start repeating this whole pattern right here over and over and over again. And you can see where this 8 starts. I'm going to start repeating 8, 5, 7, 1, 4, 2. 8, 5, 7, 1, 4, 2. That chunk is going to repeat over and over and over again. Whew! Well, that was a lot to write. So my answer is 7 point, and what repeats? This section right here, this whole chunk repeats. So I'm going to write that 8, 5, 7, 1, 4, 2. And then I'm going to write a bar or a line over that whole chunk, because that tells me this whole chunk repeats over and over and over again. So 55 sevenths is the same as 7.85714, 8571142, 8 blah, 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 going on forever. So that is how we can turn a fraction into a decimal. Just using long division, we just add decimals, add zeros, and we keep dividing until our decimal either ends or terminates, or we discover a pattern.